Hi friends, my name is Vishal Jain and I have been teaching quant for over a decade, training more than 10,000 students for various competitive exams like CAT, ZAT, CMAT, MAT, GMAT, IPM, CLAT, Bank PO, SSC and many more. In this video, I am going to share the shortcut to find out the square of any natural number. Now, I have written the square of the first 50 natural numbers here. I would recommend every student to remember the square of the first 50 natural numbers because these are some numbers which are used frequently during your calculations. Now the shortcut which I am going to discuss, there it is very essential for all the students to remember the squares of the first 30 natural numbers at least, because this will be using and this will be very handy in our calculation. So now let us start our mechanism to find out the squares of the natural numbers. First of all, I'll be taking up those numbers which are ending with 5. Now it is very easy method. Let's say we have to find out the square of 35. So step 1, take the square of 5 first of all, which is 25, and 25 will be the last two digits of 35 square. For your information, any number which ends with 5, the last two digits of its square would always be 25. So 5 square is 25. Now the remaining digits, what we will do, look at the number which is before 5. So in this case, 3 is before 5. So we'll multiply 3 with succeeding number. The succeeding number to 3 is 4. So step 2, 3 multiplied with 4 is 12. Hence our result is 1225. We'll place 12 before 25. So result would become 1225 in this case. So again I repeat, 5 square 25, 3 into 4 12. Hence our result is 1225. Again, let's say we have to find out the square of 75. Step 1, 5 square, 25. Step 2, 7 into 8, which is 56. Hence our result is 5625. 125 square. Now what if it is a 3-digit number? Again the same procedure. Last two digits would be 5 square, which is 25. And now before 5, we have 12 here. So 12 will be multiplied with 13, which is its succeeding number. 12 into 13 is 156, and our result is 15625. So this is how we find out the square of any natural number ending with 5. Now say for example, I need to find out 95 square. So 95 square, 5 square is 25, 9 into 10, 90, 9025 will be your answer. I need to find out the square of 135. So 5 square is 25, 13 into 14, that will be 182. 18225 will be your answer. So you can find out the square of any natural number following the same mechanism. Now, let us find out the square of the numbers which are made up by 1. So I am talking about only those numbers which has 1 as its digit. That is, the entire number is made by the digit 1. And this particular method is applicable up to 9 digits only. So here I am writing down the squares of the numbers which are made up by 1 up to 9 digits. Now let me explain the mechanism. 1 square is 1. 11 square is 121. These are two numbers which everybody knows only. 1 square and 11 square is very easy to find. Now what if we have 3 times 1, that is 111 square. Before we move, let me explain the shortcut. Here it is a single digit number. 1 times 1, answer is 1. When we have 2 times 1, count 1, 2, and then again move back from 2 up till 1. So 1, 2, 1. Now when it is a 3-digit number, 1, 1, 1, count up to 3, result way. 1, 2, 3, and again move back up to 1, 2, 1. So answer is 1, 2, 3, 2, 1. Counting 1, 2, 3, moving back to 1, up to 1. So 1, 2, 3, 2, 1 becomes a result. So it is 4 times 1, 1, 2, 3, 4, move back, 3, 2, 1. Answer is 1, 2, 3, 4, 3, 2, 1. So likewise, you can continue up to 9 times 1. Our result will be 1, 2, 3, 4, 5, 6, 7, 8, 9. Moving back 8, 7, 6, 5, 4, 3, 2, 1. So result becomes 1, 2, 3, 4, 5, 6, 7, 8, 9, 7, 6, 5, 4, 3, 2, 1. So if it is 5 times 1, result will be 1, 2, 3, 4, 5, 4, 3, 2, 1. If it is 6 times 1, 1, 2, 3, 4, 5, 6, 5, 4, 3, 2, 1. And this way, you can find out the square of any number which is made by the digit 1. Now, whatever methods we have discussed, we discussed it for some specific numbers, that is numbers ending with 5 or numbers which were made with 1. Now, let us talk about those numbers which lie in the range of 30 to 80. Now, basically, I am going to discuss to find out the square of any natural number. So, let's take an example of 57 square. Step 1 is to take the complement from 50. So, by complement, I mean the actual number is how much more or less than 50. So, in this case, 57 is 7 more than 50. So, complement will be plus 7. Whatever number you deal with in the range of 30 to 80, step 1 is always to take the complement from 50 only. So if your number is, let's say, 39, complement will be minus 11 because 39 is 11 less than 50. If your number is 67, complement will be 17 because 67 is 17 more than 50. So if the number is more than 50, complement will be positive. If the number is less than 50, complement will be negative. Now, step 2. Whatever complement you have got, we'll square the complement and we'll take its last 2 digits as the last 2 digits of the final result. So in this case, when we are finding the square of 57, 7 square is equal to 49. This 49 becomes the last 2 digits of 57 square. Now, in case your square of the complement is a single digit number, let's say the complement is 2. So 2 square is 4, but we have to take the last 2 digits of the square. So instead of taking 4, we'll write it as 0, 4. And if the square of the complement is a 3-digit number, let's say for example the complement is 13. So 13 square is 169. I will be taking 69 and 1 will be carried forward to the next step. Now, taking step 3 for this example, that is 57 square, you would always add or subtract the complement to 25. This 25 is fixed here. 25 as in 5 square. So 5 square plus minus complement. So whatever number you take in the range of 30 to 80, step 3 is nothing but adding or subtracting the complement from 25. So in this case, 7 was the complement. It is positive. So 25 plus 7 becomes 32. We'll place 32 before 49. Hence our result becomes 3249. So 57 square is equal to 3249. Friends, you just need to remember 3 steps. Step 1, complement from 50. Step 2, square of the complement. Step 3, 25 plus minus complement. So in this case, when we were finding the square of 57, 57 is the complement which is ideally very easily visible. So you only 2 numbers should flash in your mind. 7 square 49, 25 plus 7 32, hence our result is 3249. Now let's take one more example. Let's say we have to find out the square of 52. Step 1, complement from 50, that is plus 2. Step 2, square of the complement, that is 2 square. I'll take it as 04. Step 3, 25 plus 2, which is 27. Hence our result is 2704. Some more examples. 63 square. Step 1, complement from 50 is plus 13. Step 2, 13 square 169, but I will be taking only 69. And this 1 will be carried forward because we take only last 2 digits in step 2. Step 3, 25 plus 13, which is 38, plus 1, which was carried forward, becomes 39. Hence, our result is 3969. Isn't it easy? Now let us find out the square of 78. Step 1, plus 28, which is complement from 50. Step 2, 28 square, which is 784, but we'll be taking only 84 and 7 will be carried forward. Step 3, 25 plus 28, which is 53, and hence we'll add 7, which was carried forward to 53, which becomes 60. Our answer would be 6084. Now these were those numbers which were above 50. Let us take some more examples which lies below 50. Now 41 square, complement from 50 will be taken as minus 9 because 41 is 9 less than 50. Step 2, whether the complement is positive or negative hardly matters. You just need to square the complement. In this case, either do minus 9 square or 9 square. It is one and the same thing, that is 81. And 81 becomes the last 2 digits. Now in step 3, what we have to do? We add or subtract. Now since our Complement is negative in this case. We'll subtract 9 from 25, which is equal to 16, and hence our answer is 1681. One more example, 36 square. Step 1, complement from 50, which is minus 14. Step 2, 14 square, 196. I'll be taking 96, 1 will be carried forward. Step 3, 25 minus 14 is 11. Add 1 to it, which becomes 12. And now 1296 becomes my answer. So this is how we find out the square of any natural number which lies in the range of 30 to 80. Proceeding further, let us see a mechanism to find out the square of any natural number which lie in the range of 80 to 130 now. I believe by using your logic, you can definitely say that step 1 this time will be taking the complement of the number from 100. Now let's take an example of 108 square. So 108 is 8 more than 100. So our complement will be plus 8. Step 2 is exactly the same, which we did for the range of 30 to 80. So here we'll be taking the square of 8. 8 square is 64. Hence the last two digits will be 64. Now in step 3, there is a slight change. Whatever number you are taking to find out the square, you'll add the complement or subtract the complement from that number itself. In this case, 108 is the number. Complement is plus 8. So step 3, it says add the complement of the number 2 itself and the carried forward of step 2, write the result. So in this case, 108 plus 8 is 116. Your answer is 11664. Now this mechanism is very easy. You just have to add the complement to the number itself, which is very easy to solve. Let's take one more example. So 112 square, step 1 plus 12, which is complement from 100. Step 2, 12 square, which is 144. I'll be taking only 44, 1 will be carried forward. Step 3, 112 plus 12, which is 124. Add the carried forward 1, which is 125 now. Hence our result is 12544. Next example, 123 square. Let us solve it. Complement from 100, yes, plus 23. Square of the complement, that is 23 square, 529. I will be taking 29, 5 will be carried forward to the next step. Step 3, 123 plus 23, which is 146. Add 5 to it, it becomes 151. Hence our result is 15129, 15,129. Now let's take some examples for the numbers which are below 100. 97 square, 3 less than 100, hence complement will be minus 3. Step 2, 3 square is 0, 9. Again I'll place a 0 because 3 square is 9. So I have to make it a 2-digit number. So it becomes 0, 9. Step 3, 97 minus 3 is 94. Hence our result is 9409. Next, 81 square. So step 1, complement from 100 is minus 19. Step 2, 19 square is 361. I will be taking 61. 3 will be carried forward. Step 3, 81 minus 19 is 62. Add 3 to it, it becomes 65. Hence our result is 6561. So following the same procedure, you can find out the square of any natural number of any range. So I am writing down a mechanism here for higher numbers as well. In the first column, I am writing the range. So in this case, it is 30 to 80, 80 to 130, 130 to 180, 180 to 230, 230 to 80. And you can follow this. Now, step 1, we always have to take the complement. Now, when the number lies in the range of 30 to 80, complement is taken from 50. When the number lies in the range of 80 to 130, complement is taken from 100. When the number lies in the range of 130 to 180, complement is taken from 150. Likewise, for 180 to 30, it is 200. And for 230 to 280, complement is taken from 250. Step 2 is the same for all. That is, you need to take the square of the complement. We'll take the last 2 digits and write it as the last 2 digits of the final result. Remaining digits, if any, is carried forward to the next step. Step 3. When we deal with any number which is in the range of 30 to 80, step 3 is to take 5 square plus minus complement. 5 square when you took it from 50. Plus minus 1 time of complement. Now 5 square is equivalent to 25. Hence our result is 25 plus minus complement. Now for step 2, when you take the complement from 100, it is 10 square plus minus twice of complement, or it is ideally equivalent to number itself plus minus complement. Let me explain you with an example. We took the square of 108. 108 is 8 more than 100, so complement is plus 8. So as per step 3, 10 square is 100 plus minus twice of complement. So since our complement was positive, we'll add twice of 8 is 16. So 100 plus 16 is 116. Now 10 square plus twice of complement is nothing but 10 square plus complement plus complement. For example, in 108, 100 plus 8 plus 8. So 100 plus 8 is 108. Another 8 will add to 108. 108 plus 8 becomes 116, which is equivalent to 108 plus complement, that is number itself plus minus complement. So either it is 10 square plus minus twice of complement or number itself plus minus complement. Now following the same mechanism, when you are dealing with a number in the range of 130 to 180, it is 15 square plus minus thrice of complement. When the number is in the range of 180 to 30, that is complement is taken from 200, it is 20 square plus minus 4 times of complement. When it is taken from 250, it is 25 square plus minus 5 times of complement. And this would continue in the same manner. So this way, my friends, you can find out the square of any natural number. There is one more way to find out the square of any natural number. But before that, let me explain you something. And this we would visualize by taking this. 1 square is 1. So I have made a 1 by 1 square here. 2 square is 4, which can be written as 1 plus 3. So 1 plus 3 is equal to 4. Now when you see here, this is 1 and this is 3 squares, 3 blue squares. If I place these 3 blue squares over this red square, it makes a square of 2 by 2 complement. So 1 plus 3 is nothing but 2 square, which is equal to 4. Now 1 and 3 are the first two odd natural numbers. Mark my words. Next, when I take 3 square is equal to 9, which is 1 plus 3 plus 5. So again, I am taking the first three odd natural numbers, 1, then 3, and then 5. Now when I place the squares over and above the previous one, that is 3 squares are placed over 1, now 5 squares are placed over 3, it becomes a square of 3 by 3 component. So 3 into 3 is 9. So sum of the first three odd natural numbers is 3 square. Similarly, I can say sum of the first 4 odd natural numbers will be 4 square. Let us see, 4 square is 16. 1 plus 3 plus 5 plus 7. And it makes a square of 4 by 4 component. Hence, the sum of the first 4 odd natural numbers is 4 square. So every time when you add this consecutive odd natural numbers starting from the first until 1, the answer would always be a n by n square, which will be formed here. So to generalize, I can say sum of the first n odd natural numbers is always equal to n square. Now odd numbers has a form which is given by 2n minus 1. So for any nth odd number, if I have to find, I'll just replace n in the formula 2n minus 1. I'll get that number. So for example, I need to find out the 10th odd number. So 10th odd number is twice of 10 minus 1, which is equal to 19. Look for yourself. 1, 3, 5, 7, 9, 11, 13, 15, 17, 19. So 10th odd number is 19. So whenever we have to find out any odd number, any nth odd number, it will be replaced in the formula of 2n minus 1. One more point, if I need to find out nth odd number and n plus 1th odd numbers sum, that is always given by 4n. I am adding 2 consecutive positions of odd numbers. So say for example, I need to find out the sum of 10th odd number and 11th odd number. 10th odd number is 19 and 11th odd number is 21. 19 and 21 adds up to 40. So instead of finding out these two odd numbers, what we can do is 4 multiplied with the smaller position, that is 10 in this case. 4 into 10 is 40. Why I am saying this? Because this 3 mechanism I will be using now to find out the square of any natural number. Now let us apply this. Say for example, I need to find out the square of 221. So as I said you, sum of the first n odd numbers is n square. So 221 square can be written as sum of the first 221 odd numbers. Now this further can be written as sum of the first 220 odd numbers and 221st odd number will be added to it separately. Why I have done so? Because finding the square of 220 is easy. Sum of the first 220 odd numbers is nothing but 220 square, and this we can find out easily. 221st odd number I'll replace in the formula of 2n minus 1. Hence the next step would be 220 square plus twice of 221 minus 1. 221 square is 48400. This can be found easily. 0. So squaring it will become 00. 22 square is 484. Hence it becomes 48400. And 221st odd number is twice of 221 minus 1, which is 441. Hence our result will be 48841. Now, if we need to find out the square of 222, again it will be written as sum of the first 222 odd numbers. Now, this will be further written as sum of the first 220 odd numbers plus 221st odd number plus 222nd odd number. Now friends, we have two consecutive positioned odd numbers here, 221st odd number and 222nd odd number. So we'll apply the formula 4n for this. And sum of the first 220 odd numbers again will be 220 square. Hence our next step is 220 square plus 4 times of 221. So our answer would be 48400 plus 884, which is equal to 49284, 49,284. Now, once you practice this, you can avoid the first 2-3 steps. Directly what we can do, 222 square, in my mind, I know that I am going to break it as 220 square plus 221st plus 222nd odd number. So my result would be 48400 plus 884, 4 times of 221. Like for 221 square, I will directly come to this step, 220 square plus twice of 221 minus 1. For 222 square, since we'll be adding two odd numbers here, so it will be 220 square plus 4 times of 221. So likewise, we can proceed for any number. Now, when we come to the next number, that is 223 square. 223, when I break it as 220 odd numbers plus 221st plus 222nd plus 223rd. Now I have 3 consecutive positioned odd numbers. So in this case, instead of adding to 220, I'll be taking the sum of the 225 odd numbers first. And then I'll subtract the 225th odd number and the 224th odd number from the sum, so that I am left with the sum of the first 223 odd numbers. So now here, finding the square of any number which is ending with 5 is very easy, which we have already discussed. So 225 square minus 4 times of 224. 225 square is 5 square 25 and 22 into 23 will be 506. Hence 50625 is the square of 225. 4 times of 224 is 896. Hence our result would be 49729. So square of 223 is 49,729. Let's take the example 224 square. Again, sum of the first 224 odd numbers. By now, you must have understood. I'll be taking the sum of the first 225 odd numbers, and now I'll subtract the 225th odd number from that. So second step is this. Now, 225 odd numbers means 225 square. 225th odd number will be twice of 225 minus 1, and hence our result will be 50625 minus 449, which is equal to 50176. So the square of 224 is 50,176. Now next number will be 225. 225 square can be easily found by using the mechanism of 5 ending square. Next, 226 to 229, I'll be writing in one line only now. 226 square, sum of the first 225 odd numbers plus 226th odd number. 227 square, sum of the first 225 odd numbers plus 4 times of 226. Why 4 times of 226? Because we are going to add the 226th odd number and the 227th odd number, which is equivalent to 4 times of 226. When we deal with 228 square, we'll be taking the square up to 230 and then we'll be subtracting 230th odd number and 229th odd number. So 229th odd number plus 230th odd number is nothing but 4 times of 229. Hence, you'll be left with the sum of the first two 28 odd numbers, which is 51984. Similarly, for 229 square, sum of the first two 30 odd numbers, subtract the 230th odd number from that, and we'll get the result of 229 square, which is 52,441. So this way, you can find out the square of any natural number now. Now, let us see some facts associated with perfect squares. Number one, a perfect square never ends with 2, 3, 7 or 8. Let us look at the list of these squares. Now 1 square is 1, 2 square is 4, 3 square is 9. Let us observe the last digits of the number now. 1 square ends with 1, 2 square 4, then 9, 6, 5, 6, 9, 4, 1, 0. Can you see a pattern? 1, 4, 6, 9, 5, again coming back 6, 9, 4, 1, 0. Again 1, 4, 6, 1, 4, 9, 6, 5, 6, 9, 4, 1, 0. 1, 4, 9, 6, 5, 6, 9, 4, 1, 0. So every time if you observe, the square of the number ending with 1 or 9 ends with 1. The square of the number ending with 2 or 8 ends with 4. The square of the number ending with 3 or 7 ends with 9. Square of the number ending with 4 or 6 ends with 6. 5 ending number square would end with 5, and 0 ending number square would end with 0 only. So the last digit would always be either of 0 or 1, 4, 9, 6, 5. And that is why the square of any natural number always ends with 0, 1, 4, 5, 6, 9. Or in short, I can say it never ends with 2, 3, 7 or 8. Second fact, the last two digits of any perfect square. As I said you, square of the number would always end with either of 0, 1, 4, 5, 6, 9. Now if the last digit is 0, second last digit would always be 0. Square of any 0 ending number would always end with 2 zeros. And square of number ending with 5 would always end with 25, like we have discussed earlier. So before 5, it would always be 2. Before 0, it would always be 0. Now, what happens when the square of the number ends with 1? It is always preceded by an even digit. Say, for example, look at here. 6, when we take about 9 square, which is 81, 1, before 1, it is 8, which is an even digit. 121, before 1, we have 2, again an even digit. 361, that is square of 19, 1 is preceded by 6, again an even digit. 841, 1 preceded by 4. 2401, 1 preceded by 0. So 1 is always preceded by any of 0, 2, 4, 6, 8, and which are even digits. Now, when we take the case of 4, it is always preceded by an even digit again. When we take the case of 6, it is always preceded by an odd digit, and the square of the numbers ending with 9 would always be preceded by an even digit. Now, to understand this or to remember this in a more convenient way, I would say the second last digit is always an even digit. Only the exceptional case is 6, where the second last digit is an odd digit. Or else you can say the second last digit always form a parity of odd even combination except for 4. 1 is odd, second last digit is even. 6 is even, second last digit is odd. 9 is odd, second last digit is even. The only exceptional case is 4, which is preceded by a even digit, even combination. 0, 0 fixed, 5 se pehle 2, it is fixed. Third fact, when you divide any perfect square by 3, either it will leave a remainder of 0 or it will remain a remainder of 1. That is, any perfect square is always of the form of 3n or 3n plus 1. Next, any perfect square is always of the form of 4n or 4n plus 1. That is, when you divide by 4, either it will be perfectly divisible or it will leave a remainder of 1. These 4 facts which we have discussed can be used to eliminate any option. Mark my words, any number which follow all these 4 conditions may or may not be a perfect square. Say for example, I talk about 21. 21 is ending with 1. 21, the second last digit is 2. 21 is perfectly divisible by 3. And 21 leaves a remainder of 1 when divided by 4. But 21 is not a perfect square. So I cannot say that any number which follows all these four conditions is a perfect square. But a number which negates even one of the given condition will definitely not be a perfect square. We can eliminate that option. So any condition which is getting dissatisfied, you can directly say that the number is not a perfect square. Next fact. 7744 is the only four-digit perfect square of the form of double A, double B. Now, what is this? 7744 is the only four-digit perfect square whose first two digits are identical of one kind and last two digits are identical of second kind. 7744, for your information, is a square of 88. This factual based question has appeared in CAT once. The question was the square, I mean, a perfect square of four digit is of the form of AABB. We had to identify the number is 7744. So these are the various facts of a perfect square. Hope you would practice whatever concepts, mechanism we have discussed in this video and will make yourself comfortable with the square of any natural number. Thank you so much for joining with me and looking at my video. Thank you.